Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 3.4, the slope-intercept form of the equation of a line. In this section, we will discuss finding a line's slope and y-intercept from its equation, graphing lines in slope-intercept form, and using the slope and y-intercept to graph an equation of the form ax plus by equals c. Let's get started with a definition. Definition. The slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is the equation y equals m times x plus b. So the slope is m, the coefficient in front of x, and our y-intercept is b, the constant that's added after m times x. Example 1. What are the slope and y-intercept A, y equals 5x minus 3, and B, 7x plus y equals 6. Okay, for part A, we have the equation y equals 5x minus 3. Well, if you remember back to our definition, our slope is the coefficient in front of x, so our slope m is equal to 5, and our y-intercept, which is our b, is the constant negative 3. Okay, so in that case, our equation was given to us in exactly the same form that we wanted to find the slope and intercept from. In other words, the slope-intercept form. It was in y equals mx plus b form. For example, b, on the other hand, we don't actually have it in that form. But we can easily solve this equation for y. How do we isolate y and get it by itself? Well, first we can subtract 7x from both sides, and we get y equals negative 7x plus 6. Now, is that in slope-intercept form? Well, we have y equals, and we have something times x plus a constant, so that's in slope-intercept form. So our slope here is m equals the coefficient in front of x, which is negative 7, and our y-intercept is the constant positive 6. Okay, so that's all you do to find the slope and y-intercept of a linear equation. Okay, let's now talk about graphing a line using the slope and intercept. Okay, the steps for graphing y equals mx plus b using slope and the y-intercept. Step 1. You want to plot the y-intercept on the y-axis. And that is the point 0, comma b. Step 2, you want to use the slope m to find a second point. We want to write m as a fraction, so you can start at 0b and use the rise and run to find the second point. And step 3, our third and final step, is to use a straight edge and draw the line through the 2 points and draw arrows at both ends. Which signifies that the line continues. Okay, let's do an example where we implement these steps and you'll see how this works. Okay, example 2. We want to graph the line whose equation is y equals 3/5 x plus 1. So the first thing we want to do is to determine what our slope and y-intercept are. Our slope is the coefficient in front of x, which is 3/5. And if you remember, the slope is the rise over the run. So for every 3 units we go up in the y direction, we have to go over 5 units in the x direction. Okay. Also, our y-intercept, because this equation is in slope-intercept form, is the point 0, 1. So if you remember back to our steps, the first thing we want to do is to plot the point for the y-intercept. So 0, 1. That's our point for the y-intercept. And then we want to find a second point by using the slope. Remember, our slope is 3/5, so we'll go up 3, 1, 2, 3, and then we'll go over 5. 1, 2, 3, 4, 5. And so that's the point 5, 4. And then we can use a straight edge. Bring up my ruler here to go through those 2 points. And then draw arrows at both ends. Okay, so that's how I would graph that equation. So we'll bring that back up. I want to show you a dotted line here. So again, we go rise 3 units and run 5 units. Okay, let's go back. So we rise 3 units and we run 5 units. So that's how we found our second point. Okay, let's try another example. Okay, example number 3. We want to graph the line whose equation is 3x plus 4y equal to 0. Now we'll want to do the same thing as we did in the previous example where we find the slope and the y-intercept. But notice that this equation is not written in slope-intercept form. So what we want to do is we want to solve that equation for y. We want to isolate y by itself. So to get y by itself, we can subtract 3x from both sides of the equation, and we get 4y is equal to negative 3x plus 0, but we'll just leave that off. We know it's there. Then we can divide both sides of the equation by 4. The 4's on the left cancel, and we get y equals negative 3 over 4 times x. So our slope is the coefficient in front of x, which is negative 3 over 4, which is the same as our rise over our run. So for every 3 units I go down in the y direction, I will go over 4 units in the x direction. So this line is going to fall from left to right. That's not exactly what it will look like, but that's the general idea. Okay, our y-intercept, well, normally it would be b, but since b is 0, our y-intercept is just 0, 0. So we can start at that point, 0, 0. Okay, and then we want to do our rise of -3, so down 3, 1, 2, 3, and our run of 4, 1, 2, 3, 4, and that's our second point right here at 4, -3. Okay, and then we can use our straight edge and line those points up. Do a little better than that, I think. And then draw a line through those points. Put arrows at both ends. And that is our graphed equation. So again, to go back, as we did last time, we are going to rise -3 and run 4. So our rise is -3 units, and our run is 4 units to the right. Okay, that is how you graph equations of a linear equation using the slope and y-intercept, both when it's in slope-intercept form and when it's not. That is the last example for this section. Good luck on your homework. Please let me know if you have any questions as you go through it, and I'll see you in the next